Okay, we're going to continue with angles with 2-2 angle relationships. Some of the things that we were going to talk about, pretty much introducing some new vocabulary words. We're going to talk about complementary and supplementary angles. We're going to talk about perpendicular lines. Again, bam, look at those. Those are my definitions right there. And then we're going to demonstrate what can and cannot be assumed when we look at diagrams. Never make any assumptions in diagrams. There are specific notations in geometry that allow us to know things. We do not assume them. Okay, so as we begin with complementary and supplementary angles. Complementary angles, those are a pair of angles that when we sum them together, they equal 90 degrees. So here in this, I have angle JKL, and I have angle CBA. This, it would be JKL plus ABC would be 30 plus 60 is 90. That's a complementary angle set, angle pair. They do not have to be adjacent or touching. They just have to sum to 90 degrees. And then here we happen to have, two adjacent angles that when I add them together, 67 plus 23 is equal to 90 degrees. So then I know that QRS is complementary to SRT. That's the concept of complementary angles. And then supplementary angles will sum to 180 degrees. So here I have DEF is 110 degrees. I have angle GHJ is 70 degrees. 110 plus 70 is 180 degrees. Therefore, these two angles are supplementary. And then here, same thing. I have angle UVW, and I have WVX add to 180 degrees. 135 plus 45 is 180 degrees. I also can look at that and say they are a linear pair. Those two angles form a straight line, and we know that from previous that a linear pair are supplementary. They equal 180 degrees. I will say that, let's see here, these pairs are supplementary and complementary and supplementary angles. Pairs of angles that are complementary or supplementary do not have to be adjacent, right? So they do not have to be touching. They just have to sum to either 90 or 180 degrees. And I will say that sometimes we get confused with complementary and supplementary, which is which. I will say, well, they're in alphabetical order. If I think 90 and 180, numerically, they are in alphabetical order, complementary and supplementary. Also, my wife told me that, well, when I have two angles that seem to form, when two angles form a right angle, they look like a corner and complementary both begin with C. Two supplementary angles form a straight line. So straight and supplementary both begin with S. So there you go. There's help us keep those definitions in order. And then here, so as we start using some of this information, complementary and supplementary angles, it says find the measure of two complementary angles if the measure of the larger angle is 5 more than 4 times the measure of the smaller angle. Okay, I know that if I have two angles, and I'm just going to name them angle 1 and angle 2, if they are complementary, they equal 90 degrees. And then it says if the measure of the larger angle is 5 more than 4 times the measure of the smaller angle. Well, we'll just call angle 1 the smaller angle, and then they said the larger angle was 5 more plus 5 than 4 times the smaller angle. 4 times angle 1 would be equal to 90 degrees. We don't know what angle 1 is, so we just call that my unknown. And that's how they came up with this equation. X, angle 1 is unknown, and then that other one is 5 more than 4 times. And then there you go. That's how they came up with that equation to figure out what my angle values were. So there you go. Combining like terms, 4x and 5x is, x and 4x is 5x. 5x plus 5 is equal to 90. They subtracted 5 from both sides. 5x equals 85. And then when we divide both sides by 5, right, divide by the coefficient, x is going to be equal to 17. So the smaller of the angles should be equal to 17 degrees. That means the larger angle was 4x plus 5. 4 times 17 plus 5, so that would be 68 plus 5, or 73. So the measures of the angles are 17 degrees and 73 degrees. And it says here, check, do your answers seem reasonable? Usually when they ask you something like that, give an explanation. Is something reasonable? Use your definition and use definition and then solve, I sort of think. If together they are supposed to be complementary, that means they are supposed to equal 90 degrees. And when I go back and check it, add them together, bam, they're 90 degrees. So that is it. Let's see here. Now, looking at this check, it talks about usually just trying to come up with the equations is the hard part. But this says the difference between the measures of two supplementary angles is 18 degrees. Let's see the difference. If I angle 1 minus angle 2, the difference is 18 degrees. I don't know what each one of those angles are, but I do know the difference is subtraction. And then the measure of the smaller angle is blank, and the measure of the larger angle is blank. Well, I do know that they're supplementary. So I know that angle 1 plus angle 2 should equal 180 degrees. Now I just need to do some substitution. We did this in algebra a lot, but if I take this equation right here and I isolate angle 1, that would be angle 1 is equal to 18 degrees plus angle 2 by, adding angle 2 to both sides, right? So now if I'm able to come up with that substitution, I can now plug it back in my equation. So instead of using angle 1, I'm going to use 18 degrees plus angle 2 plus, I'm going to bring that down, angle 2 equals 180 degrees. I know 18 degrees plus 2 times angle 2, because there's two angle 2's now, is equal to 180 degrees. Subtract 18 from both sides. 2 times angle 2 is equal to 162 degrees. Divide both sides by 2. And let's see here. So that means angle 2 is going to be equal to 81 degrees. All right. Does that seem to make sense? If angle 2 is 81 degrees, the measure of the smaller angle is 81 degrees. Let's see here, 81 degrees plus angle 1 is equal to 180 degrees. So I'm thinking minus 81 from both sides. Angle 1 is 99 degrees. So the difference between them is 18 degrees. We add them together, it's 180 degrees. So the measure of the smaller angle is actually 81 degrees, and the measure of the larger angle is 99 degrees. Okay, and that's it. That's how we're using this information. Okay, looking back at that problem, I will just say that instead of using angle 2 along the way, you could have used x and y. So hopefully that's not, it would have worked out the same. So just how well you want to work with your variables. Now looking here, next, perpendicularity. Line segments or rays that intersect at right angles are perpendicular. So when we see perpendicular, we know we have 90 degrees intersections. So those are right angles, and right angle symbol indicates that the lines are perpendicular. What is the right angle symbol? Right angle symbol. The right angle symbol. This is my right angle symbol, right there. That means that those two lines intersect at 90 degrees. Perpendicular lines intersect and form 4 right angles. okay? This is, just think about it. If this is a straight line, then I know that this angle should be 180 degrees minus 90 degrees, which is 90, because that would be a linear pair. So, yep, that would be 90 degrees. And then if I know vertical angles, these two angles are vertical, so they are congruent, so that's 90 degrees. These two angles are congruent, so that's 90 degrees. So therefore, perpendicular lines intersect and form 4 right angles. If I have one right angle, I know that the other 3 are going to be perpendicular now. Saves me a lot of math, And I'll just say here as a study tip, I'm lazy, so I don't write perpendicular out. I use this symbol, perpendicular. That little upside down T is read perpendicular to. So here, looking at this, segment AC is perpendicular to DB. And that's what we have here. Segment AC is perpendicular to DB. And we want to be able to communicate that, because I tell you, I'm going to stop writing perpendicular because that takes forever. And then let's see here. Perpendicular lines intersect to form congruent adjacent angles. Well, we just talked about that up here and we're able to prove it. But again, if this is 90 degrees, then this would be 180 minus 90, also 90. So those adjacent angles would be 90 and 90. This would be 90, so these two adjacent angles would be 90. These two adjacent angles would be 90. These two adjacent angles would be 90. So all of that works out using our definitions. Okay, as we continue to work with these examples with perpendicular lines, tanagrams. A tanagram is a puzzle consisting of 7 flat shapes called tans, which are put together to form shapes. Find the values of x and y such that AD, line AD and line EC in the tanagram are perpendicular. So they are wanting us to find the measurement, a value of x and y, that this and this, these two lines intersect at a 90-degree angle. If that's the case, then the things that we would want to see occur is this measurement right here should be 90 degrees. So angle ABC should be equal to, which is 3y plus 15, should be equal to 90. Equal to 90. Okay, that would give us the proper definition, or the proper solution. Subtracting 15 from both sides, I have 3y is equal to 75, divide both sides by 3, and y is equal to 25. Let's see, what else could I do? In that case, vertical angles, I know then the sum of these two angles over here should add up to 90 degrees, because they should be, if they are if it is intended to be right angles, then those two angles would be complementary, therefore they would add up to 90 degrees. So they should equal 90 degrees. Putting in substitution for those two angles, make it equal to 90, combine like terms, I get 15x plus 15 is equal to 90. I go ahead and subtract 15 from both sides, and 15x is equal to 75, divide both sides by 15, and x is equal to 5, I believe. 5. So there you go. That turns out that that's how we can solve for x, solve for y. And let's see if I think we're able to use those definitions and figure out what we needed. So here on this one, in this check, it says find the values of x and y such that PR and ray QS are perpendicular. So again, this should be perpendicular, so this should be 90 degrees, this should be 90 degrees. So in order to find y, I got 4y minus 2 is equal to 90. In order to find x, I should have 5x plus 6 plus 2x equals 90. And those equations will give me the information that I need. I'll do the easy one first. Add 2 to both sides. 4y equals 92 divided by 4. Y is equal to 23, I think. And then 23, and then x, combine like terms. I have 7x plus 6 is equal to 90. Subtract 6 from both sides. 7x equals 84 divided by 7. And x is going to be equal to 10, 11, and 12. So x is equal to 12. There you go, using the definitions that we have. All right, so using, again, we make no assumptions in math or in geometry because we have indications or we have proper notation that will tell us what things are equal to. But here it says interpreting diagrams, things that we can see, things that we can't. I'm going to go right here that cannot be assumed. When we look at a diagram, we cannot assume something is perpendicular. We cannot assume that it is congruent unless they have those arcs, those tick marks, the perpendicular or the right angle measurement. So looking at this, I have nothing to show that these are congruent. I have nothing to show that they are right angles. I can assume that right here, that's a straight line. So I know that we could have a linear pair. I could have some linear pairs. I don't know that anything has been bisected. I do know that like HL, that's a ray. I know that this angle, GHL added to JHL, that's 180 degrees, so those guys would be a linear pair. There's a lot of things that we can look at diagrams and know, but not assume. Okay, and then here, this is a good example. I do know that this angle and this angle are vertical angles, so they are congruent. I do know that this angle is vertical to this angle. I know that, so I don't have to assume. And I also know that, for example, ABD, and it tells me CBE are vertical, and I know that EBA and ABD form a straight line, so they're linear pairs. Again, things that we know that we don't assume. Now, I'm going to go ahead and fill in some of these real quick. Okay, so looking at some of this information, I would just say that things, if I look at right now, I know that there are no tick marks or arcs, so congruency, angles will have to be vertical to be congruent. I know that there are no right angle measurements, so in order for there to be a right angle, I can't assume that, I don't know that, so I'm just going to say that, let's see, what can we do now? Complementary angles, that forms a 90 degree. I have no way to know anything is 90 degrees, so that's how I could easily eliminate that just looking at my diagram. But I guess if I don't jump ahead, angle array CF and CE are opposite rays, so they do have a common endpoint. They're opposite rays, so I know that they form a straight line. Let's see here, and I can see the line right here. BGC and KGC are a linear pair because two of their sides are opposite sides. Their non-common sides are opposite rays. Let's see here, ABJ and CBG are opposite angles, so they're vertical, so they are congruent. Let's see here, BCG and DCF, these have no relationship of any kind that we have identified, so we can't say anything about those. Okay, so that's why it's a no. No relationship that we've introduced yet. Let's see here, BE and IF. We don't know that they're perpendicular because, again, if they were perpendicular, I would have some form of right angle indication. So that's a no. Already talked about this one. ICH, and HCD, let's see, it says are adjacent angles. Yeah, sure, it looks like it, right? We have a common vertex, a common side, so yeah, they are adjacent. And then angle bisectors, we don't see any congruency arcs, so angle bisectors are out. So there you go, just things that we're not assuming, it's things that we know, and that's what we work with. Here in this last example, which statements cannot be assumed given the figure? All right, KHJ, and GHM are complementary. We don't know that. We don't know that those two angles are 90 degrees. I think GHM and JHK are congruent, right, according to those arcs. So that's something. I know that that's not the case. What else do we know? GHK, and then JHK are a linear pair. That is true. We can see that the two non-adjacent sides form opposite rays. HL is perpendicular to HJ. HL is perpendicular to HJ. That is not the case, okay? It is perpendicular to HM, so that's a no. GHM and MHK are adjacent. That is true. That's a true statement. GHM and MHK, they are adjacent. That is true. They share a side and a vertex. And then HL is perpendicular to HM. We just said a second ago, yes, that is true. So those are things that we know and versus things that we do not know when it comes to math. And all of these things that we understand and know, those are definitions, and we'll use them in the future. For example, again, when they have a linear pair, I know that they equal 180 degrees. When they're adjacent, I don't have any definitions, but I do know that when they're perpendicular, they equal 90 degrees. So these things we're going to be able to work with.